The car is traveling at 2 meters per second and then accelerates to 10 meters per second in 4 seconds. The car then travels at 10 meters per second for 20 seconds. Suddenly the driver sticks on the brakes and the car comes to rest in 2 seconds. Plot a velocity time graph, right, to show this stuff. So let's have a straight line here now. There's the vertical axis and there's the horizontal axis. Just turn that off. Now I have some blue here. So we're going to put the time down here, T for time, right? And that's in seconds. We're heading from left to right. There's the arrow. Here we have velocity. Velocity. And the units there is meters per second. So the car is traveling at 2 meters per second, right? So the velocities mentioned here with 2 meters per second and 10 meters per second. So we can scale our graph here. This will be 0 down here, 0 time and 0 velocity. And up here then we say we're going to call this 10. That's going to be 10 meters per second. Halfway down then will be about 5 meters per second. And halfway down there then that'd be 2.5, wouldn't it? You know? And then halfway between 5 and 10 there would be 7.5. Now this would be easier to do on graph paper. Anyway, the time then, we're out to, we've 20 seconds here. The car travels for 20 seconds and then, so we have, look, we have 4 seconds, that's 24, and then we've 2 more is 26. So let's say we have a total of 30 seconds of interest, right? So we'll call that 30, and we'll call that 15. Maybe something like, we could call that then 20 and 25, does that make sense? And then that'll be 10 and that'll be 5 seconds. Right, so we're ready to go now. Let's go for red maybe for, then the car is traveling at 2 meters per second, so the car is here. Or it's 2, well 2 is going to be like 4/5 of the way up, hopefully it's somewhere here, right? The car is traveling at 2 meters per second, and what happens then? It's at 2 meters per second, then it accelerates to 10 meters per second in 4 seconds. So by the time we get to the timer clicks out to tick, the clock is ticking, right? And by the time it gets to 4 seconds, the car is doing 10 meters per second. Right, so it's going to be up here doing 10 meters per second at 4 seconds. So we can join those guys there with a straight line. Right, so that represents acceleration there. And then what happens? The car then travels at this new velocity, 10 meters per second, for 20 seconds. So that's 4 at plus 20 will bring us up to 24. So we'll be up almost at 25. We'll be about there. So again, I'm going to get my straight line tool here. The car is cruising along for 20 seconds at 10 meters per second. So that brings us up to the 24th second in our little world here. Then what happens? Suddenly the driver has to apply the brakes and the car comes to rest. Now rest is 0. Rest equals 0 meters per second, right? So it comes to rest in 2 seconds. So that's 24 and 2 is going to be 26. So it'll be there, roughly. So it's it's going to be a steep line, which represents sudden deceleration and negative acceleration. So let's see this again now, just to make sure we've done stuff right. A car is traveling at 2 meters per second. Right, here it is traveling at 2 meters per second when our story starts, if you like. Then accelerates to 10 meters per second in 4 seconds. So when after the stopwatch has run 4 seconds, the car is doing 10 meters per second. Then it cruises at 10 meters per second for 20 meters per cruises at 10 meters per second for 20 seconds, which would bring us up to 4 plus the 20 will bring us up to 24 seconds. And then suddenly we brake, and within 2 seconds we're going 0 meters per second. So that's at 24 and 2 gives us 26 seconds on the clock there. Plot the velocity time graph. So that's it done there. Right? Smiley face. That'll do.